Okay, so exercise 15.4, question 18. The diagram shows a minor sector OAB of a circle of radius r and angle theta in radians. The perimeter of the sector is 12 and its area is A. Express theta in terms of r. Okay, well, what we got to remember is that this length here, L we'll call it, L equals r theta. Okay, so we know that much, and what we also know is that the full perimeter, so that's the two radiuses added together and L, so r plus L equals 12. So we're going to get 2r plus r theta ends up to be 12. So what we're going to get next is r theta equals 12 minus 2r. Theta therefore is equal to 12 minus 2r all over r. Now what I want you to show next is show that the area equals 6r minus r squared. Well, we just had to look up the area formula of a sector. Okay, so what is the area formula of a sector? Area formula of a sector is half r squared theta, which is going to be a half r squared 12 minus 2r all over r. This r cancels with this r. 2 into 12 goes 6 times, 2 into 2r goes r times, so we're going to end up with 6. It's going to be r multiplied with 6 minus r, which is going to get me 6r minus r squared is the area. Find the maximum value of A and the corresponding value of theta. Well, what we know is that this graph here, what's the graph is? It's an n-shaped function because of the minus r squared. We know it has a maximum. What I need to do first is differentiate it. I get 6 minus 2r. At the maximum the slope equals 0, so now I'm going to get 6 equals 2r, r equals 3. So that's the ADR. Next I'm going to get the second derivative, prove it's a maximum. The ADR squared is going to be minus 2. Minus 2 is less than 0, so therefore it's a max. Now what I need to find out next is what theta is. So I need to find out the maximum volume as well. Is it maximum volume or maximum area? Maximum value of area, excuse me. So area equals 6r minus r squared. So area is going to be 6 times 3 minus 3 squared. Maximum value of area is going to be 9. Is it 9 centimeters squared? Yeah, 9 centimeters squared. Now I have to find out what theta is. The formula for theta is 12 minus 2r all over r. So theta equals 12 minus 2r all over 12 minus 2r all over r. R is equal to 3. So it's going to be 12 minus 2 times 3, which is 6 all over 3, which is 6 divided by 3 equals 2. Theta equals 2 radians. Okay, that's that question answered. Moving on to number 20. An open cylinder can, keyword on open, with no lid, has a base radius r and a height of h. Find the total outer surface area of the can is 300 pi centimeters cubed. Express h in terms of r. Well, we have the total surface area, TSA, equals the curved surface area, which is in red. Now the curved surface area is represented by actually a rectangle, which is 2 pi r when you unravel the bottom by h. So it's 2 pi r h is the curved surface area, and then it's going to be plus the area of the circle on the bottom, which is pi r squared. Total surface area therefore is 2 pi r h plus pi r squared h, pi r squared. Now we know that the total surface area is 300. And now we got to isolate h. H needs to go on its own, so it's going to be 300 minus pi r squared equals 2 pi r h. Bring 2 pi r h underneath, so we're going to get 300 minus pi r squared. Now we need to divide that by we need to divide each one by 2 pi r and 2 pi r because I want them separate. So when this happens, so we're going to divide everything on this side by 2 pi r. So what's going to happen is it's going to be 150 over pi r. These pi's cancel here. This radius cancel this one. It's going to be minus r over 2. So this is h here. So look, we can get a common denominator actually if we do want. So look, we'll put that as 2, that is 2, and then multiply this by pi r, multiply this by pi r. Let's go back where we were. It's going to be 300 minus pi r squared all over 2 pi r. We'll just leave it like that for the time being. Now we're looking for the volume. Show that the volume of a cylinder is pi r squared h, which is going to be pi r squared multiplied by 300 minus pi r squared all over 2 pi r. Now what's going to happen here is that this r here can cancel with this one here, this pi here can cancel with this pi here, and what we're going to get is multiplying in by r, we're going to get 300r minus pi r cubed all over 2. Break that in half, we're going to get 150r minus pi r cubed all over 2 equals v. And that's what we're asked to do. Now find the dimensions of the can that can give a maximum volume, calculate the maximum volume. So dimensions of the can that gives the maximum volume, get the maximum volume. Okay, so what I'm going to do here is I'm going to do the VDR. The VDR represents the rate at which the volume is changing with respect to the radius. We want the slope of this to be 0 because we're expecting a turning point, and I think the turning point we're looking for is a maximum. So we want the slope to be 0. Okay, so what we're going to do is we're going to get 150, and then we're going to 3 goes to the front, and we're going to get 3. When you differentiate r cubed, you're going to get 3 pi r squared. Oh, sorry, 3r squared. Sorry, excuse me. So it's going to be 3 pi r squared all over 2, and this has to equal 0. Now, while we're here, we might as well do the second derivative to verify it's a maximum. The 150 disappears, and what we're going to get is multiplied by 2 again, so we're going to get minus 6 pi r, take 1 away from there, and then what we're going to get is minus 6 pi r over 2, which is minus 3 pi r. Radius always has to be positive, so this is less than 0, hence it's a max. Now back to solving this here, what we're going to get is 3 over 2 pi r squared. 3 over 2 pi r squared equals 150. Multiply by 2 to get 300. Divide by 3 to get 100. So pi r squared equals 100. R equals 100 over pi. R equals the square root of 100 over pi. Okay, so we found out what R is. R is 100 over pi. This doesn't quite seem right, so what actually happened here was this here was actually a pi. So it took it down wrong, it was 300 pi. So then 300 pi is still 300 pi, is still 300 pi here, which makes it 300 pi here. So the height is 300 pi all over pi r squared. So these pi's can cancel now. So that's where that problem kicked in. So that pi is gone, that pi is gone. So it's 300, h equals 300 minus r squared all over 2r. Okay. Sorry guys, so we're just changing this up here, okay, so it is pi r squared h, and there's just a quick mistake in there, so it was meant to be 300 minus r squared all over 2r. So what happens here was the pi didn't cancel because the pi was already gone. So what we got here was pi. So this r squared cancelled this r here, multiplied in by pi, and we get 300 pi minus pi r squared all over 2. And what we get is 150 pi minus pi r squared all over 2. Now, when we put this into this formula, pi r cubed over 2, so when we put the pi back in, so we're going to have pi r here, and what happens is now it's much different because it's now 300 pi, and the pi's will cancel off both sides. So what we're going to get is r squared equals 300, okay, and therefore r equals 10. R squared equals 100, and therefore r equals 10. So the radius equals 10, which is much better than 100 over the square root of pi, which is a very complex answer. So now we know the radius is 10. Upon knowing that the radius is 10, we now need to figure out what the height is. So the height is going to be 300 minus the radius squared, which is going to be 10 squared, all divided by 2 times 10. H is going to be what's it going to be, 200, so 300 minus 100, which is 200, divided by 20. H is also going to equal 10. So we know r is 10 and h is 10. So r equals 10, h equals 10. Now we have to find out the maximum volume. Well, the maximum volume is pi r squared h. It's going to be pi times 10 squared times 10. It's going to be 1000 pi. Okay.